Hey there, and welcome back to another episode of chemistry. And of course, today we are going to conclude our discussion on carbohydrates. We are going to be looking at the reactions of glucose. Reactions of glucose. Okay, so in the previous episode, we looked at the preparation of of glucose. Okay, we saw the laboratory method for preparing glucose as well as the commercial method from starch. All right, so do not forget that this tutorial is brought to you by the O3 Schools JAMB CBT practice app. It is all you need to succeed in your exam. Let us see a question, a JAMB pass question from the application. This is a 2008 question, number 42. Okay, it says if glucose is heated with concentrated tetraoxophosphoric acid, it will be dehydrated to A says carbon, B says carbon 4 oxide, C says ethene, D says ethanol. Okay, so we'll come back to answer this question at the end of the class and not before. The reason is that at O3 Schools, we believe in giving you value first. We believe, say, once we don't teach you to answer question, no go be your problem. So we want to teach you first so that you know. Once you know, you have known. All right. So please make sure you download the application from Play Store, the O3 School JAMB app. Ask all the past questions that you need for your exam, so you don't need to bother about going to buy past questions. Okay, it also has, of course, a lecture notes structured according to the JAMB syllabus for your study. Then it has question search feature where you can search for questions, just like the way we search for this question. You can search for question according to topic, and all the questions that JAMB has set, okay, under that topic will come out for you to answer. Then what is more important, of course, is the mock challenge on the app every Saturday by 10 a.m. Okay, in that mock challenge, compete with all students that are writing JAMB for this particular year. Okay, compete with them, you win amazing prizes, get used to JAMB past questions, get you to JAMB likely exam questions, familiarize yourself with the format and ways JAMB twist questions, as well as see your result released every Saturday. Thereby, you're able to track your preparation for the exam. You know, will be scared when they say JAMB don't release the result, because results what they see every day. Okay, so you got that, your confidence has already been worked on. Okay, so please jump on the app, download it. It's available for your Android phone on Play Store, and also if you want to download it for your computer system, for your laptops, okay, go to o3schools.com/JAMB app. All right, if you need help or further help, download it for your computer. Simply send a message to this number on WhatsApp. That's 091-2151-5246. Now let's see the reactions of glucose. All right, now the very first one we will consider is dehydration of glucose. Okay, dehydration of glucose. Okay, so now when concentrated tetraoxophosphoric acid, concentrated H2SO4 acts on glucose, okay, what happens is that the water molecules that are present, okay, in glucose will be completely taken out by this concentrated tetraoxophosphoric acid, because this tetraoxophosphoric acid is a very strong dehydrating agent. Okay, so it will dehydrate it. By dehydration, we mean it is removing water molecules. Okay, it is removing it. It will draw it out. Then it will now leave a deposit, a black deposit of copper. Okay, copper. Okay, so I say copper carbon to leave a black deposit of carbon. Okay, this black deposit of carbon that it is left behind after the dehydration, or I usually call it sugar charcoal. We call it sugar charcoal. Okay, this sugar charcoal is usually called one of the purest form of amorphous carbon. The purest form of amorphous carbon. Carbon. All right, so please take note of that. So when glucose is dehydrated by a very strong dehydrating agent, okay, what happens is it yields a deposit of black copper. All right, so that black copper is actually called sugar charcoal, and we call that sugar charcoal a very pure form of amorphous carbon. All right, so now that is dehydration of glucose. Take note of that. It will happen in the presence of concentrated tetraoxophosphoric acid. All right, now let us go to another reaction that glucose undergoes. Okay, number 2 is action of hydrogen iodide. Now, before we continue, you should take note that most of the reactions that glucose undergo, most of them is usually what kind of what a test for what? For glucose itself. Okay, you said that you are testing for the number of carbon atoms that are present in glucose, or you are testing if glucose has a carbonyl group in its formula, or you are testing if there's an alcohol present in what? In glucose, and so on and so forth. All right, so we're going to see most of the tests now. Okay, it will what? Point us to one of two of what? Of these what? Reasons. So let us continue. Number 2. Now we're going to look at what? The action of hydrogen iodide. Okay, so the action of what? Of iodide, of what? Of hydrogen iodide on glucose. Okay, when hydrogen iodide, which is called what? Which is what? Our HI, when it acts on what? On glucose, what it gives to us is what? Is a normal hexane. Okay, it gives to us a normal hexane. Let us see that reaction. This is our glucose, CHO. Then we now have what? Our C. There, here we have our what? Our H. Here we have our OH. All right, then here we have our C again. Okay, here we have what? Our HO. Okay, here we have what? Our what? Our H. Then here we have our C again. Here we have what? Our what? OH. Okay, here we have our H. Then we have our C again. How many C now? C. Okay, have our what? Our OH. You have what? Our H. Then we now have our CH2OH. Okay, so this is like the full diagram of our glucose. Okay, so when hydrogen iodide, okay, HI, okay, acts on what? On this, what it gives to us is what? Is N-hexane. N-hexane is same thing as what? As normal hexane. That is, we are going to have CH3, okay, CH2 into 4, then CH3. Okay, these are what? Our normal hexane. Okay, so the action of hydrogen iodide, okay, on what? On our glucose gives us what? A normal hexane. This usually shows that there are what? That there are 6 carbon atoms present in glucose. So this is what it tells us, okay, that there are what? 6 carbon atoms present in what? In the glucose what? Compound, okay? So 6 is H12O6, and we can verify that because the formula for what? For glucose is what? 6H12O6. Take note of what? Of that. Very, very simple. So this is the second reaction we consider, the action of hydrogen iodide on what? On glucose. Then number 3, we proceed. Now we're going to look at the action of hydroxylamine. Okay, the action of hydroxylamine and hydrogen cyanide. The action of hydroxylamine and what? Hydrogen cyanide. That will be our third reaction we are considering. Number 3. Okay, action of what? Hydroxylamine and hydrogen cyanide. Hydrogen cyanide is what? Is HCN. Hydroxylamine is what? NH2OH. Okay, so the action of what? Hydroxylamine and what? And hydrogen cyanide, okay, is another what? Reaction that what? That glucose what undergoes. What these two reactions tells us is that what? That there's a carbonyl group present in the formula of what? Of glucose. Okay, that is, we usually have what? This carbonyl, C-O-O. Okay, we have a carbonyl group present in what? In glucose. This is what this reaction tells us. Now let us see the first one. So if we have our glucose, let me just say, should I just say 6 is H12O6 to make it easy, or let me just draw it out? I'm going to have your CHO, then I'm going to have your 1, 2, 3, 4 CH2OH. Okay, yes, what? H, yes, OH, yes, HO, yes, H, yes, H, yes, OH, yes, H, yes, OH. Okay, so the action of what? Of hydroxylamine, NH2OH. Okay, what this gives to us is glucosine. Okay, it gives us what? Glucosine. Glucosine is the product of what? Of this what? Reaction. Glucosine is what? Is drawn like this. You have what? Your CH. Okay, double to what? To N and what? OH. Then you have what? Your CH. CHOH into 4 places. Then I have what? Your CH2OH, then plus H2O. This is your glucosine, okay? Glucosine. Okay, that is what the product of what of this reaction. So when hydroxylamine acts on what? On glucose. This is our glucose. When hydroxylamine acts on what? On glucose, what it gives to us is what? Is glucosine. Okay, and the purpose of this reaction is to show us that what? That there is a carbonyl group present in what? In the formula of what? Of glucose. Also, when hydrogen cyanide acts on what? On glucose, okay, it gives us what? It gives us what we call cyanohydrine. Okay, it gives us what? Glucocyanohydrine. Okay, and also ACN action on what? On glucose also tells us that there's a what? That there's a carbonyl group present in what? In the formula of glucose. Okay, that's why I was telling you that what? And most of the reactions that we're going to consider, they are going to be pointing us towards what? Test for what? For glucose. All right, so please stay put. Now that is what the the third reaction we consider. Then number 4, we're going to be looking at the action of bromine water. The action of bromine water. Bromine water is HOBr. Bromine water is HOBr. The action of bromine water. All right, so number 2, sorry, number 4 now. That is action of bromine water. Okay, bromine water is HOBr. Okay, and when bromine water acts on glucose, what it gives to us is what? Gluconic acid. We have what? Gluconic acid. Okay, when bromine water HOBr acts on what? On glucose, what we have is what? Is gluconic acid. All right, now let us check gluconic acid. What is what? How do we get what? The gluconic acid. Now, basically, what does this reaction also will tell us? This action of bromine water, this specific reaction tells us that the carbonyl group that is present, okay, is an aldehyde. It confirms that what? That the carbonyl group, okay, that is present is what? Is an aldehyde. It is not what? An amide. It is not what? A ketone, okay. It is what? It is an aldehyde, okay. So the action of bromine water on what? On glucose confirms to us that what? That the carbonyl group that is present is an aldehyde. Okay, so this specific reaction will tell you that okay, it's an aldehyde that is here. So it's a glucose. Glucose has an aldehyde functional group. So it's not fructose, actually, it's a what? It's a glucose. So it confirms that the carbonyl group that is present is an aldehyde. So the action of bromine water on what? On glucose. So let us see that reaction to give us what? Gluconic acid. So we're going to have what? Our glucose as usual, CHO. All right, 1, 2, 3, 4, CH2OH. Okay, HOH, HOH, HOH. Okay, so the action now of what? Of bromine water, HOBr. Okay, when it acts on this, what it gives to us is what? It's our gluconic acid. Our gluconic acid is what? COOH. Okay, CHOH into 4 places, then CH2OH. These are what? Our gluconic acid. Okay, and this confirms to us that the carbonyl group that is present in what? In this what? In the glucose is a what? It's an aldehyde what? Functional what? Group is an aldehyde. Okay, it's an aldehyde. That the carbonyl group present is what? Is an aldehyde. That is what the purpose of the what? The action of bromine water on glucose. Now let us see the very last one. The very last one will be the action of what? Hydrogen triazonitrate 5, which is what? HNO3. The action of hydrogen triazonitrate 5. Action of HNO3. HNO3. Okay, so the action of what? HNO3, okay, on what? On glucose. What does it tell us? Okay, it tells us what? That a primary alcohol is present in what? In glucose. Okay, a primary or alcohol is present in glucose. That is what the action of HNO3 tells us. So let us see the reaction. We have our glucose as usual. I shouldn't have cleaned the last one, CH. All right, so I'm going to have our OH, H, okay, HO. All right, I'm going to have your H, then H, CH2OH. Okay, then here I'm going to have our OH, here I'm going to have our H, here H, our OH. Okay, so the action of HNO3, okay, on what? On glucose, it gives us what we call saccaric acid. Saccaric acid. Okay, this is what it gives to us. Okay, and to the structure is COOH. Okay, bonded to what? CHOH into 4 places. Then what? I'm going to have what? Our COOH. These are what? Our saccaric acid. Okay, and it is very, very important to note. It's very, very important to note here that what? This saccaric acid can also be gotten by what? By reacting, okay, by reacting or what? By allowing what? The action of hydrogen triosnitrate 5 to act on gluconic acid. Okay, if hydrogen triosnitrate 5, HNO3 acts on gluconic acid, okay, that is COOH, this is our gluconic acid, CHOH into 4 places, then CH2OH. Okay, so if HNO3 acts on this gluconic acid, what it gives to us also is what? Is saccaric acid. We're also going to have a saccaric acid now, but it confirms to all that there's a primary alcohol present in what? In the glucose. Okay, so please take note of what? Of all of these. They are important. If they are not important, I will have told you so. All right, so this is where we're going to stop. Let us go to the O3 School JAMB CBT Practice app and answer the question we have, and we'll be done with this. Now, 2008, number 42, it says, if glucose is heated with concentrated tetraoxovic acid, it will be dehydrated to what? What will it give us? A says carbon, B says carbon dioxide, C says ethene, D says ethanol. Okay, correct answer there will be what? Will be carbon. Okay, a black deposit of what? Of carbon will be deposited. All right, and that is called sugar charcoal. Okay, one of the purest form, or if not the purest form of what? Of amorphous carbon. All right, so there are many other questions on this application. Ensure you what? You download the app from Play Store and start practicing your way to success. You do not have time to waste. My name is Master T. I'm the Grand Commander of this army. Join our Telegram group and of course get latest information as soldiers. See you in the next episode where we'll talk about what? Another what? Macromolecule like lipids. Thank you.